All right, we first new vocabulary term today. Angle of elevation. Angle of elevation. And instead of just me drawing this little right triangle and saying, there's the angle, this is the best I could do. You can bust my chops for it, fine. But this is the best I could do here. All right, so we got Johnson. I have no idea what he's in right now. I have no idea what that is. All right, but he's looking straight ahead. Okay, he's looking straight ahead. So his line of vision, straight ahead, makes a horizontal line. All good? All of a sudden, a plane flies above his head, and he wants to look at the plane. So take a look right now, the angle he's going to start forming. Okay, so he was looking straight ahead, and then he saw the plane up, and everyone see the new angle that was formed right here. This is called an angle of elevation. When you look up at something after you're looking straight ahead. All right, and if I move the plane up or down, I think I can do this. Yep. See how the angle of elevation changes. All right, so again, it started looking straight ahead, and then once he saw the plane, that angle of elevation changed. Okay, so angle of elevation is when you're looking straight ahead, then see something up in the air, on top of a building, in a tree, you make a new angle. That's called angle of elevation. All right, when your eyes go up. All good there. Okay, let's see if we can design one ourselves here with Scott looking at the top of the tree for a bird. All right. Okay. Okay, yeah. All right. So Scott's eye level, 1.5 meters above the ground. So from ground to eye is 1.5 meters. So let's just, not his height, but just his eye level, 1.5 meters from the ground. Okay, so eye to ground is 1.5. And Scott's standing 30 meters from the tree. So from Scott to the tree, 30 meters. I think we can confidently put 30 meters here. All right, now comes the new vocabulary term. The angle of elevation to the top of the tree is 36. So remember how elevation is formed. Ready? Scott was looking straight ahead, but then he saw the bird at the top of the tree. So he looked up, and everyone see that angle he created. Looking straight ahead, then up to the bird, that angle of elevation, 36 degrees. How far above the ground is the bird? Ooh. So from the ground all the way up to the bird, how far is it? Well, my first question, do you see a right triangle we can make from the angle of elevation? Make it. Go ahead, make that right triangle now. Make a right triangle using your angle of elevation. So have a right triangle with the 36 on it. Hopefully most of you are just drawing a vertical line down, right? Here you go. Oh boy, I still got issues. I got the 36 degrees, but I need a side too to work with. Can anybody label a side length on that triangle? Side length. Anybody see a side that you know what the measure is? Because I need one. I need a side length to start. Here we go. Get right back to you, Johnson. 15. Any other side length you can tell me? 30. If that's 30, he's 30 meters away. So is this. 30 meters. Now, I may not be able to solve for the entire problem from bird to ground, but do we have enough information to solve from bird to his eyesight? Yes, we do. And then maybe someone could tell me, oh, after you do that, this is how I find my final answer. So let's find that leg right now. Same way we've been finding every side. Sine, cosine, tangent. Tell me what sides we have. No. Josh, 10? Yes, we don't have an 11. What's the x and the 30, Josh, from the 36? Good work. And the 30? Good work. All right, so what ratio can I use here? 24? Tangent. Let's roll. Tangent. (36) equals opposite x over adjacent 30. This is what, third day we're setting these up now? So hopefully we're getting more comfortable with them. Put it over 1. What are we not doing here? Rounding. Yeah, this isn't going to be my final answer. Don't round this bad boy. Not my final answer. You guys getting about 21 and change? Okay, good. Not my final answer. So 21.79627584. There's that distance right there, but I would need to find the bird to the ground. So final piece here to my answer I just got. 15 to get from to the bird to the ground. To get from the bird to the ground, what do I need to do to this 21 here? Just use the number, Molly. Thank you for your explanation. 1.5, good. There you go, right? Add his line of sight in. And now we can round. So we're looking nearest 10th now, nearest 10th. 23.3. I'll wait. It's naked.
Oh, yeah, numbers
Units. There's no change in units here, but gotta have units. So elevation, straight ahead, I look up, I make a new angle, looking up. Questions? All right, now let's talk about looking down on an object instead. So now instead, Johnson's going to see a boat in the water. Refresh here. All right, so he's still looking straight ahead, and all of a sudden, a boat comes down, and he sees the boat. So now he's looking down. That's called angle of depression. Depression, I'm looking down. Elevation, I'm looking up. Hey, look at my diagram up here. Can you guys see a right triangle you can make out of this?
Yeah.
Maybe some of you see one I could do right here. Or does anybody see the other one right here? Right, so there's two right triangles I could possibly use using depression. So does everyone see the difference between depression and elevation? All right. Thanks there, Johnson. Appreciate it. So let's go back to our celebrity here, Big Al. He's at the top of the building. He sees one of his buddies coming towards the top, towards the building. It makes an angle of depression of 40. Everyone ready? Angle of depression. I was looking straight ahead, right? He was looking straight ahead, but then saw his friend down below. See the angle that it made? Right here, 40 degrees. Looking straight ahead, now looking down. That angle's 40. All right, what else do we know here? Rooftop, 16 meters from the ground. So 16 meters right there. And his eye level, 1.8 meters from the rooftop. 1.8 is eyesight. What's the distance between Big Al's friend and the building? Can you figure out what we're finding? Where are you going to put your X here? Big Al's friend in the building. Throw an X on your diagram. Where is that? Right here? Between him and the building. All right, can we see a right triangle I can work with? Okay, I'm going to pick one because I know we could, let's take a look. We could draw a vertical line up here and deal with that one, but on purpose, I'm going to use this one. I want to use that right triangle for one reason. Here's why. See where the 40 is? It's not inside the triangle I'm using. I can't use it. I need an angle inside the right triangle to do sine, cosine, tangent. That 40 is not inside, but use it. Somebody use the 40 to get to an angle inside my right triangle that I chose. Jackson?
That angle on the ground
Wow. Everyone hear that? Wow. Somebody's taking over Jackson today. 40. This is also 40. Remember, alternate interior. All right, so that's 40. Or if you didn't want to go that way, anybody could tell how to find the angle adjacent to 40. Right next to it. This is what right here? What type of angle here? A right angle. So if you could say if that's 40, this is 50. Fine. Fine. Jackson gave me that one first, so I'll use that one. And let's all face it, everybody, right? Even blind squirrels find an acorn sometimes, right? 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 So it happens. Some of you guys picking that up. Good. From the 40. I'm proud of you, Jackson. Way to go. I'll talk to you in May 8th, all right? For the next one. 40. What's the 16 in the X if I use 40? 12. What's the 16 here?
16 is opposite.
Yes, it is. And X is?
Adjacent.
So I can use which ratio? 20. Which ratio can we use here? Tangent. Yep. Tangent of 40. All right, here's something else we got to talk about. What's going to go in for opposite? Not 16. Right? Not 16.
17.
Look at my triangle. 16 is not the full side. Carter, what is?
17.
16 and the 1.8. So I got to put my opposite side 17.8. That you got to use the full side over adjacent X. There we go. Go ahead, cross multiply. You do have to do a little division here at the end, right? Got to divide both sides by the tangent of 40. Just make sure we stick to our rounding directions. Nearest tenth. Whew. Whenever you're ready with that calculation, let me know. Whenever you're ready. Who do we got up? 24. Whenever you're ready over there, Romeo. 20 or 21? 21.2 feet.
Meters.
One job, meters. Questions? Elevation, I'm looking up. Depression, I'm looking down. Starting from looking straight ahead. All right, depression problem here. Now we'll go to a lighthouse. I don't know, anybody ever been in a lighthouse? All right, good story. So a person spots a ship, angle of depression is 20 from the top of the lighthouse. So how do we make this now? Ready? I always start. I was looking straight ahead. All right? I was looking straight ahead, but then I saw the boat down below. And that angle I just formed, 20 degrees. Make sure you form it with the horizontal line. What else do we know here? The lighthouse is 28 meters tall. The lighthouse only, 28 meters. And the cliff is 45 meters tall. What's the horizontal distance? Horizontal distance between the lighthouse and the ship. Where are we putting our X here? Yeah?
The distance between the cliff and the ship.
The horizontal distance, right? Not the vertical distance or the diagonal distance. Horizontal distance, right? All right, everyone sees our right triangle? Again, you could draw this line up and do the right triangle like that. That's fine. I'm going to use this one. What do you guys prefer? You want to use the complementary angle or the alternate interior? Alternate interior? Okay. So we could put this as 20, or you could say that's 70, remember? It's up to you. What sides do you have? 8. What sides? What's the X?
X is the adjacent.
And the 28 and the 45 side?
Opposite.
Opposite. So what ratio are we going to continue to use here? 2. Oh, man. 10, Josh. Tangent. Good work. Tangent of 20 equals, what are you guys putting in for the opposite side? Can't use 45, can't use 28. Got to combine them to get 70. 73 over X. Yep. What do we got? Nearest 1/10 of a meter again. 1/10 of a meter when you're ready. Oh, 24, Romeo, come on.
200.6 meters.
There you go. Way to redeem yourself. See, the generator knows. All right, any issues? Final one I'm going to do with you because you're doing the last one in your group. Final one we're doing together. Make your own diagram. This is when I love just walking around and seeing your artistic abilities or lack of. Because mine aren't any better. All right, so here we go. Angle of elevation to an airplane viewed from a control tower. All right, here we go. Warm it up. Control tower time. Control tower. Great. To an airplane in the sky, right? There we go. There's a beautiful airplane. Remember, elevation. We looking up or down?
Up.
Okay, ready? You were looking straight ahead. Up, there's my airplane. Sure, probably would have put a little higher, but all right. 7 degrees. There it is, 7 degrees. All right, there's some other pieces here. The tower, 200 feet high. This tower, 200 feet high. And I want to talk about this because I think this will come up in the homework tonight. The altitude of the plane is 5,200. That means from the ground right up to the plane is 5,200. Altitude of a plane is from the ground directly up. So from the ground directly to the plane is 5,200 feet. That's what altitude of a plane means. Directly above the plane is 5,200 feet. All right, everyone see my right triangle? Hopefully we do right here. Shoot. And we're looking for what? What is the diagonal? Little different from number 3, right? Number 3, I asked for the horizontal distance between them. Now I'm asking for the diagonal distance. So now I know I'm solving for that side. I will specify horizontal or diagonal for you. What other side do we know in that triangle? I know we're solving for X and I got the 7 degrees. I need another side here. What's up, Zach? I know the vertical leg. Yep, right here. Now let me talk to somebody else. How can I find that distance right there? My diagram obviously not drawn to scale, but how do I find how long that leg is right there? Look at all the information I have given you. How can I find that leg? Scott?
You subtract the 200 from the 5,200.
5,200 minus the control tower. This is going to be 500 feet. Sorry, 5,000 feet. Excuse me. All right, go ahead. I won't even ask anybody. Figure out what you got. What do you have? Opposite, adjacent, hypotenuse, and which one of the 3 do you need? Are we viewing this plane from a control tower or from a mushroom for some of your diagrams? For a nuclear plant, Jack? Yeah, that's fine. Brought to you by the letter T. Don't eat, you go ahead. Go ahead and comment. I'm good. Go ahead. We'll go back and forth.
Yours does look like a mushroom.
Yeah, you never said one.
It's behind there. Yeah.
Dude, I've never gone
Looks good. We all should be using the sine ratio here. Sine of 7, 500 over x. Nearest foot, 41,000. Sorry, 41. 41,028 feet. I should have changed this one, Luke. I should have said how many miles. See if people were paying. You like that column? How many miles away are they? I gotta convert. Questions? Anything? All right, you are going to do the next one in your group, but before you do, I'd like to go over a couple properties of a rhombus that may help you out here. All right, properties of a rhombus. Yeah. Okay, you may need that. I think next May you will need that. Diagonals bisect each other. Anybody remember anything else about a rhombus, Callum? That's where we're going to get our right triangles. Diagonals perpendicular. Yep, that's where you're going to get your right triangles to do sine, cosine, tangent. And it says find the side of a rhombus for part B. Doesn't matter which side. Why not? All sides congruent. Yeah, so it doesn't matter which side you find. All right, go ahead. I'll be peeking around here, seeing how you guys are doing on this one. Making sure you get the correct. Actually, you know what? I'm just going to give you the answers here. If you can't get these answers, call me over. When you do get the answers, start on the homework. So let's see. Part A here should be BD equals 72. And side equals 54. Okay, don't cheat, please. If you can't get those answers for parts A and B, let me know. If you can, keep going on into the homework. Talk to each other. Talk to me if you need to. Find a right triangle first. Find an angle and a side. And then solve for your missing side. Don't struggle in silence. Let me know. If you do get 72 and 54, great work. Keep grinding to the homework.
You came at 10, why did you say hi? Yeah, well, I'm gonna put the test. You could like reach I was maybe I don't make a tractor. Not that way. Yeah, not that way. If you told me I would have. Because we didn't need to. She gets paid for it.